Hello, in this video, we're going to evaluate this function, the limit of this sine x over 5x plus tangent x as x approaches 0. Okay, so let's just start at once and plug in our values of x into this equation. That's just it, alright? So the limit as x approaches 0 would just become, let's plug in 0 for x in this equation. We're going to have sine 0 over, in place of x, over, indicate that as x approaches 0, that will just become sine 0 over 5 times 0 plus tangent of 0. Okay. Right. So doing this, we'll have the limit of x as x approaches 0 of this function. Now sine 0 is what? Sine 0 is 0 over 5 times 0 is 0 plus tangent 0 is 0. So we see an indeterminate form. So we say the limit of this should be 0 over 0. I know that this is not allowed. Okay? Therefore, we should employ another method to solving this kind of problem, because the limit of this function as x approaches 0 is giving us 0 over 0, which is indeterminate. We can't determine a certain value for that. So we are not going to make use of this. Now when we evaluate the limit of a function and a result gets to an indeterminate value, 0 over 0, I would say we differentiate the numerator and denominator of the function and find the limit again. So the limit, so let's differentiate this function using L'Hopital's rule. That will become the derivative with respect to x of the numerator sine x divided by the derivative with respect to x of the denominator 5x plus tangent of x. Okay, so this will become the derivative of sine x is just cosine x divided by, now sum of the derivative of sum is the sum of the derivatives. So derivative of 5x is 5 plus the derivative of tangent x is secant squared x. Okay, so I believe at this point we can try again, okay, if we would have a specific value for the function. So this is the derived function, and we have cosine x over 5 plus secant squared x. So we're going to find the derivative of this, the limit, sorry, of this function as x approaches 0. So that will become cosine of 0 divided by 5 plus secant square 0. Secant of square 0. Okay, so the cosine of 0 is what? You know the cosine of 0 is 1 divided by 5 plus. Now, secant square 0, you know that secant is the inverse of cosine, okay? So 1 over cosine of an angle is equal to secant of an angle. So 1 over 1, where cosine 0 is 1. 1 over 1 will give us 1. Therefore, secant 0 is 1. So secant square 0 is just 1 square, which is still 1. So this will become 1 over 6. Right. So this value is the limit as it approaches this using the L'Hopital's